All right, it is 10 o'clock. I feel like the moderators always say I'm very excited to introduce the speaker, but I am actually very excited to introduce today's speaker. I like that we're talking about methods because they're relevant across all of our shared disciplines. And Field has done quite a bit thinking about methods. And Dr. Field Watts is currently a postdoc at UW-Milwaukee, and we're very excited to have him there. With that, Field, take it away.
Yeah, thank you for that introduction, Johnny, and good morning, everyone, and thank you all for being here. Like Johnny said, my name is Field Watts, and I'm a postdoctoral researcher at the University of Wisconsin-Milwaukee. So I'm really excited to have this opportunity to share some of the methodological things I've been thinking about at X-DBER, and since the conference theme this morning is education research methods, I'll be sort of sharing a narrative from my career so far about the different projects I've worked on using different methodologies. And at the end of the talk, I'll sort of share a little bit of a reflection on the research paradigms that are underlying these projects. So to begin, I want to just give some context sort of for who I am and how I've approached structuring this talk. So I recently completed my Ph.D. in chemistry education research. I actually defended in December under my advisor, Professor Ginger Schultz at the University of Michigan. And then since then, I've been, like I said, working as a postdoc at University of Wisconsin-Milwaukee. So for the talk, I'll be taking somewhat of a chronological approach, kind of telling the story of how I got involved with different methods as my research interests developed. So I'll start with my first project during my PhD program, where I was sort of tasked with doing this qualitative analysis of responses to a chemistry writing to learn assignment. And then from there, I'll take a little bit of a detour into a project that grew out of that, where I was interested in investigating methods within chemistry education research for establishing reliability for qualitative studies. And then from there, I'll return back to the Writing to Learn project and talk about how I sort of translated that qualitative analysis into a more automated approach using machine learning with the goal to deliver automated formative feedback on students' writing. And then from there, I'll end with that reflection I mentioned about sort of navigating between these qualitative and quantitative approaches and the underlying research paradigms. So sort of jumping right in, my first project as a grad student was really based in the literature on organic chemistry students reasoning and learning about reaction mechanisms. And this literature really emphasizes how organic chemistry instruction needs to focus on supporting students with considering all the various properties that are relevant to reaction mechanisms, while also developing appropriate chemical reasoning. So for example, students need to consider properties like acid-base chemistry or things like electronegativity. And then the reasoning that they're trying to develop is mechanistic and causal reasoning as they're using those different properties to think about mechanisms. So the instructional approach that we've sort of focused on in my research group at the University of Michigan was writing to learn assignments. So these are essentially writing assignments that are intended to support students' conceptual learning and disciplinary thinking. So I'd like to contrast writing to learn assignments with learning to write assignments, where learning to write is really focused on teaching students about how to actually engage in the writing process. So teaching students maybe how to write lab reports, for examples, whereas writing to learn really focuses on using the writing process to get students to be thinking through concepts. So with these writing to learn assignments, we've specifically used them to promote conceptual thinking through eliciting students' written explanations of various topics in organic chemistry. So including things like resonance, acid-base chemistry, and then the focus of what I'm sharing today, reaction mechanisms. And so this is part of a much larger project at the University of Michigan called MWrite, with co-PIs, my advisor, Professor Ginger Schultz, and then Professor Ann Geer from the Education and English departments at Michigan. And so this program is really focused on supporting instructors with implementing writing to learn assignments in STEM courses broadly. So since 2016, when the program started, it's supported over 18 faculty members across 12 departments and 65 courses, and by now, well over 35,000 undergraduates with engaging in writing to learn assignments across a variety of STEM disciplines. So for the specific project that I was kind of tasked with when I started my graduate career, we were looking at a writing to learn assignment in the context of a second semester organic chemistry laboratory course. And then one of the key features of the Writing to Learn assignments in this course and across courses from the MWrite program is this Writing to Learn process, where students first submit a draft to the writing to the assignment, and then they undergo a structured peer review process that's really focused on giving and receiving feedback on the content of the assignment rather than the writing quality. And then after that, students have time to revise their writing based on peer review and submit a final draft. So then the specific assignment that I focused on for this project presented students with this molecule thalidomide, and they were given the context about how the molecule was used as a drug to treat pregnant women for morning sickness around the time of World War II. And eventually it was discovered that the drug caused harmful birth defects. And so one of the possible causes of these birth defects is the hydrolysis reaction that happens whenever you ingest this drug. And so students were shown the molecule thalidomide, and they were also given 2 of these hydrolysis products. And essentially the writing task that students were given with this context was to describe and explain the mechanism for the formation of both of those hydrolysis products. And so the research question with looking at students' responses to this writing assignment was, how are students reasoning about reaction mechanisms in their writing? So to approach that research question, I worked with my mentor at the time, Dr. Jennifer Schmidt-McCormack, who was a postdoc in the group. And we focused on analyzing students' revised drafts so we could see what concepts and features about mechanistic reasoning they were including in the writing after they've had the chance to really go through the writing process. And so what we did for this analysis was we developed a framework for characterizing mechanistic reasoning in the organic chemistry context. So to develop this framework, we used a combination of both deductive and inductive coding to develop a coding scheme. So on the left here, the setup conditions, identifying entities, and other things in that column, those are all drawn from the philosophy of science literature for what to expect in discourse around mechanisms broadly across science. And so using that framework as a starting point, we generated a set of deductive codes for what we could imagine aligning with those features of the framework for the context of organic reaction mechanisms. And then through the qualitative analysis process of reading all of these students' drafts, working on coding them deductively, we were also just keeping an eye out and inductively coding for additional features that we were able to see in students' writing. So the focus of this talk isn't really about the actual content of the framework, but really more on engaging in this sort of combination of inductive and deductive coding to develop this framework. So after we were kind of settling upon all of these different features that we were seeing, we were interested in using this framework to address that question of how are students reasoning about reaction mechanisms in their writing. And as you can imagine, with this kind of complicated writing task and complicated framework, I was really interested methodologically in how we can ensure that we're reliably analyzing students' writing. So that question spurred another project that I eventually started working on with another postdoc in the Schultz group, Dr. Solaire Finkenstadt-Quinn. And so for this project, we conducted a review of the chemistry education research literature with a focus on investigating the methods researchers were using to establish and report reliability for qualitative research. And so for this project, we reviewed 573 articles involving qualitative analysis of some sort that were published between 2010 and 2019 in the 2 primary journals for chemistry education research. And so as we were analyzing these articles, we were interested in whether they included things like a reliability measure, some discussion of a negotiated agreement, or general discussions of reliability or trustworthiness. And then just to give a snapshot of our results, here you can see, first of all, just how the number of qualitative research articles published in these journals really increased over these 10 years. And then we can also see the breakdown of the different ways researchers were kind of pointing to this idea of reliability or trustworthiness. So to go through these results, several studies were including some measure of reliability. So these are inter-rater reliability measures, which are essentially a numerical value of how consistently two or more researchers are applying the same codes to the same units of data. So these measures are most commonly included things like percent agreement or correlation coefficients, which are typically regarded as less robust measures of agreement, along with chance-corrected agreement coefficients, things like Cohen's kappa or Krippendorff's alpha, which are generally regarded as more appropriate measures for agreement in this type of content analysis. And then a similar thing that we were seeing across these studies were researchers reporting a process of negotiated agreement. So this entailed two or more researchers agreeing on the same codes for the same units of data that served as the data set for the study. And then we saw several researchers reporting both a measure and discussing following that with negotiated agreement process. And then the final sort of category that we saw from the set of studies that we're discussing reliability in some way, we're mentioning it without providing an actual measure or discussion of a negotiated agreement specifically. And so these were typically discussions of the concept of trustworthiness. So engaging in various practices to sort of get at the same thing that a reliability measure gets at. So this could be discussing the analysis with the research team, engaging in triangulation, so using different data sources to see if what they're measuring is consistent across different sets of data. Engaging in member checking, so this often happens with interviews where those researchers go back to the participants to see if what they're finding aligns with what the participants intended. And then also discussing the analysis with outside researchers not involved directly with the project. And so what I want to highlight sort of from these findings are that there were kind of two different approaches that researchers were taking to establish this notion of reliability or trustworthiness for their analyses. So there's the conventional approach and then the naturalistic approach. So the conventional approach aligns more with kind of the typical expectations for scientific research. So appealing to the concepts of validity, so whether the findings are reflecting the phenomenon of interest, reliability, which is whether those findings are consistent, and then the concept of objectivity, which is whether or not the findings are reflecting reality. And then in contrast, the naturalistic approach, which is drawn from more qualitative methodological traditions, appealed to reliability in a different way by discussing things like credibility, whether the findings were true, transferability, which is the degree to which findings might be applicable across other contexts, dependability, which most closely reflects the notion of reliability specifically, which is whether the findings are consistent or repeatable, and then confirmability, which is understanding how much the findings are shaped by participants rather than researcher bias. And so the key takeaway from sort of presenting these two different approaches is that either approach supports researchers and practitioners with understanding and interpreting the analysis and findings of the study. And I think for whichever approach you take, it's valuable to include some detailed and transparent description within the methods of the article, so readers of your work can understand more deeply your analytical process. So now going back into that Writing to Learn project where I sort of posed that methodological question, ultimately, I decided to take the more conventional approach with this project, where I analyzed 30% of the coded data with another researcher. And then we calculated a fuzzy kappa of 0.81, which indicated near perfect agreement. So fuzzy kappa is a variation of Cohen's kappa, which is a chance-corrected agreement measure, allowing for multiple codes to be applied to each unit of analysis. And so the reason I sort of took that conventional approach was because I was interested in looking at sort of broader trends across the data set that we were analyzing. So this is just a small snapshot of the data, showing the percent of students that included these different features at least once in their response to the writing assignment. So these are two broad categories of the coding scheme that we developed related to identifying activities and identifying properties. So activities tend to or reflect really how the mechanism happens. So in the context of these organic chemistry tasks, describing the underlying electron movement that guides the mechanism as it transforms from the starting material to the product. And we can see that across the board, 85% and more students were including these activities within their response, which is a positive finding because that's really one of the key goals of this writing to learn assignment, was to engage students with really thinking about the underlying activities that happen as the mechanism progresses. And then the other aspect of this scheme is identifying properties. So this reflects deeper reasoning about exactly why the mechanism is happening. So in the context of these chemistry tasks, this is referring to more implicit properties that guide how the molecules are interacting. So acid-base interactions, or nucleophilicity and electrophilicity, and how these actually are guiding how the molecules interact with one another. And as you can see from this snapshot of the results, only between like 50 to 65% of students were including these in their response. And so this kind of points to a place where maybe we could be improving our instruction around this topic so that students are thinking more deeply, not only about how the mechanism happens, but why the mechanism happens. So the key sort of takeaway from this is that through analyzing writing, we can gain some insight into the features that students are considering in their reasoning. And then just from the snapshot of the results I shared right now, this can lead to questions like, how can we better support students' considerations of these implicit properties? And then as a researcher, I'm sort of considering things like maybe we can adjust the language in the prompt to better direct students towards considering these properties. Or maybe we could adjust the peer review process so that it's really focusing on implicit properties. Or maybe we could give students direct feedback that guides them towards considering more deeply what's happening in the mechanism. But as you can imagine, at a large university like the University of Michigan, a big challenge with either doing research on these assignments or investigating how adjusting the instructional aspects of the assignment change and influence students' reasoning is the fact that there's a lot of student writing. So this graph here shows the course where we were implementing the assignments, and we typically implement these in the winter semester, which are shown by the purple bars. So anywhere between 800 to 850 students were typically enrolled in this course in the terms where we implemented these assignments. And then I'll remind you about the writing to learn process, where students were submitting a first draft, undergoing peer review, and then submitting a revised draft. So each student was submitting 2 drafts for each writing to learn assignment, and then we would typically do 3 writing to learn assignments per semester. So you can just imagine the sheer number of drafts that students are producing over the course of the semester, and how challenging it can be to analyze those as a researcher in order to investigate whether or not small changes are producing change in students' reasoning, and also as an instructor with the idea of giving feedback. So this motivated the research question of whether we could use automated text analysis to identify these features of mechanistic reasoning present across students' responses. And so to do that, in my first year of my program, I taught myself how to code in Python. And then eventually Dr. Amber Dude joined the group as a postdoc, and she brought a lot of experience with machine learning. And so we developed machine learning models to essentially automate the analysis that I did from that qualitative analysis at the beginning. So what this involved was using the framework that we had developed to analyze over 1,200 sentences of students' responses to these writing to learn assignments. And I just want to highlight that in doing that analysis, we reached through several rounds of coding these sentences between 70 to 80% agreement with 0.62 to 0.74 for that fuzzy kappa value. So these represent kind of more moderate agreement measures, indicating how challenging it can be even for 2 experienced researchers to be doing this analysis. And then after doing the analysis, we did discuss and come to complete agreement for all of the codes that were applied. And so what this analysis actually looked like was basically taking each of those 1,200 sentences and then essentially just tagging whether or not those features were present in that individual sentence. And then what we did is we trained individual machine learning models for each of those features. So what this entailed was taking those labeled responses, so essentially the data set of 1,200 sentences with whether or not the feature is present, and then splitting that data into a training set, a validation set, and a testing set. And then we use a neural network classifier, which is a deep learning model for essentially training the machine to predict whether or not those features are present. So it uses the training set and the validation set to sort of adjust how much these hidden layers essentially vote for whether or not the feature is present. And then once the model is developed, we used that held out testing set in order to evaluate the model, which just involved comparing these human scores to computer scores, where the 0 reflects that the feature is not present and the 1 means that it is present. So we did that for all of the features in the coding scheme. And this graph here shows the performance of those machine learning models. So the comparison between human and computer assigned codes. So the darker circles here represent percent agreement, whereas the orange circles represent the Cohen's kappa chance corrected agreement measure between the human and computer. So across the board, we can see that we were reaching high percent agreements. And then this red line in the middle at 0.7 reflects the cutoff for assessment for even high stakes automated writing evaluations. Like for example, the GRE has the writing component and it's automatically scored using similar approaches. And the cutoff for that context is a 0.7 kappa value for those models. So the key finding here is that overall we were successful in developing these accurate machine learning models for identifying these features in students' writing that were related to mechanistic reasoning. And then this led to the research question of whether we could use these models to automatically analyze student writing and use that automated analysis to provide immediate informative feedback. So what we did is we developed a tool using Streamlit. So Streamlit is an open source Python platform for developing web-based applications. So essentially, we could link to this application on Canvas or the course's learning management system, and students would be able to then use it anytime during the writing process to get automated feedback. So the first 2 paragraphs here just sort of tell students what the goals of the writing assignment are, and then how to use the feedback tool. And then I'll show you sort of how it works. So essentially students can copy and paste their response into the text box and click submit. Then you can see in the top right corner here that it takes just a couple of seconds to run. And then students can scroll down and sort of see the initial output from that automated analysis. So showing them what features are present in their response. And these are color coded based on kind of how important they are pedagogically speaking. Then students can go over to the sidebar here and read expanded definitions for each of those features, just so that it's clear sort of what it's looking for in terms of within their writing. And then finally, students can scroll down and receive targeted written feedback, suggesting what they can focus on within their revisions. And so essentially how this tool works is that it takes the students' writing and then it uses the machine learning models to automatically classify all of the sentences within the student's response. And then it compares that individual response to the corpus of prior responses that we have for these writing to learn assignments. And then based on that comparison, their students are given tailored feedback depending on sort of where they stand in terms of their individual response comparing to the set of prior responses. So for majority of the features, if they're below the 25th quartile or below average, they'll receive targeted feedback to focus on including more discussion of those features. Whereas for a couple of the features that the organic education research literature indicates reflect more surface level thinking, if students are above average for those, they're given targeted feedback to consider how they could be more specific in their explanations. And so the key finding from this is that we can use this automated approach to develop these feedback tools. And then just from a pilot study that we did using this tool in the interview setting, we did find that it showed promise for promoting students' self-regulated learning with these writing to learn assignments. So to kind of tie all these pieces together with translating the qualitative findings into practical solutions with this machine learning approach, my sort of first study as a graduate student using the qualitative analysis showed how we can analyze student writing and get some insight into how students are reasoning. And then we can also develop machine learning models to identify those features of students' writing, which can then be transformed into tools like the one I just showed you for providing this automated informative feedback. So this is just one example with one type of assignment. And what I want to highlight is how I think this can represent a really kind of fruitful direction for moving forward in terms of supporting or eliciting and assessing students for kind of more complex and open-ended tasks. So writing to learn just represents one type of assignment or task reported in the organic education literature, all of which share the feature of eliciting explanations from students. And then I think this shows sort of a pathway for how we can apply machine learning methods to analyze and classify student responses to these open-ended explanations, and then use automated methods to deliver adaptive and individualized interventions. So things like tutorials or scaffolds or the formative feedback tool that I showed today. Okay, so now I sort of want to take a step back and do that reflection that I talked about at the beginning of the talk. So thinking about what it means to navigate between these methodological traditions when doing mixed methods research. So going back to the study where I looked at approaches for appealing to reliability or trustworthiness, I'll remind you about the two different approaches that we saw across the literature for appealing to this construct, the conventional and naturalistic approach. And what I want to introduce now is how these approaches can align with the common education research paradigms. So specifically, the conventional approach typically aligns with this positivist paradigm where the focus is really on empirical data and logical reasoning. So really aligned with Western scientific practice. Whereas the naturalistic approach, which, as I mentioned earlier, is more grounded in qualitative research methods, tends to align more with interpretivist and critical theory paradigms. So the interpretivist paradigm focuses more on human experience and localized meanings, whereas the critical theory kind of builds on interpretivist paradigm, but with a specific focus on inequality and power dynamics. So with these kind of paradigms in mind, I kind of want to discuss the role of the paradigms in shaping sort of my ideas as a mixed methods researcher. So when I first kind of learned about these paradigms, they sort of seemed separate from the research I was doing and not really tied to what I was working on. And it was unclear to me sort of why they mattered. And if anything, they just seemed like kind of convoluted ways to say that I was doing quantitative research aligned with the positivist paradigm or qualitative research aligned with interpretivist or critical theory paradigms. But sort of over the years of my PhD, I sort of have been crossing the line between doing pure qualitative and quantitative research. So it's become more apparent to me how reflecting on these paradigms can make me more deeply understand my research and what I'm working on. So another kind of important aspect of this reflection is the context in which I was working on these projects. So I started my PhD in 2018, right in the middle of Trump's presidency. And then just 2 years later in 2020, we had the onset of the COVID pandemic. And then just 2 months into the quarantine, George Floyd was murdered at the hands of police. And the Black Lives Matter movement really reached its height. So kind of throughout the time of my PhD, in the different spaces I was in on campus and in my research group and in my own time during quarantine, sitting alone at home, I was engaging in a lot of self-reflection and then discussions on campus regarding anti-racism. And within my research group, we were specifically thinking about how we might unknowingly be perpetuating racism in our research. So this is important when considering the paradigms because of kind of what they're typically associated with. So the positivist paradigm is typically associated with Western science and the concept of naive realism. And it typically and then the interpretivist paradigm, in contrast, focuses more on privileging indigenous and non-Western viewpoints. And then the critical theory paradigm builds on that by focusing on the ideas of post-colonialism and emancipation. And then each of these paradigms are also associated with specific methodological kind of traditions. So positivism really focused on quantitative research with experimental designs and interventions. Interpretivism focused more on qualitative research and sense-making and doing studies in naturalistic settings. And then critical theory focusing more on qualitative research with this specific focus on policy and history and really challenging dominant narratives. So thinking about these paradigms, I was really kind of asking myself, what it means to engage in the research that I was doing that possibly navigates between these paradigms. And then I was kind of asking myself whether my research, which kind of admittedly aligns somewhere between positivism and interpretivism, whether that research aligns with my values. And then kind of methodologically, I became really interested in this question of how paradigms are reflected in the education research literature. And because paradigms are often not explicitly stated within research articles, this motivated a review that I'm in the process of working on to look at frameworks in education research. So I'm working on this project with Dr. Soler Finkenstadt-Quinn in the Schultz group, and then also with my current advisor, John Mark Rodriguez, and then Jocelyn Nardo, a postdoc at Stanford. So for this project, we are investigating the frameworks that researchers are using in education research articles. And just for a small snapshot that I'm going to share today, I'm going to focus in on the 457 articles we've looked at so far, published between 2018 and 2021 within the chemistry education research journals. And for this part of the project, we've been looking at the presence of different frameworks across these articles and whether they are kind of housed in a distinct framework section. So just like the smallest part of this project I'm going to share with you is sort of the large collection of different frameworks that we've been seeing across the literature. So these just represent a really small sample of the different frameworks we've been seeing across all of these studies. And as we've been going through and trying to make sense of all of the different types of research that is out there, we've been aligning these frameworks with kind of the three categories of theoretical frameworks that are presented in Bodner and Orgill's theoretical frameworks for research in chemistry science education handbook. So these are constructivist frameworks, hermeneutic frameworks, and critical theory frameworks. So looking at sort of the definitions of these frameworks broadly, based on the Bodner and Orgill definitions, they sort of suggest what this research that uses those frameworks might be focusing on. So studies using constructivist frameworks tend to focus on the nature, structure, and development of knowledge. Hermeneutic frameworks tend to focus more on how students or teachers experience the learning process or the learning environment. Whereas critical theory frameworks tend to focus on tend to belong to studies that are investigating power structures and inequities within learning environments. And what I want to kind of highlight is how roughly these different categories of frameworks align with those paradigms that I talked about earlier, the positivist, interpretivist, and critical theory paradigms, respectively. So kind of the key takeaway just from sharing this snapshot of those results so far is that we're kind of seeing how the framework guiding a study can implicitly reflect the paradigm that's underlying the research. So to sort of conclude the talk, I kind of want to end on this question of why do paradigms matter? So the underlying paradigms really do shape the methods that we're using, whether or not we recognize what paradigm we're working within or not. So a paradigm might shape what framework we're using to guide our analysis or guide our study. A paradigm can shape whether we choose to privilege qualitative or quantitative data. And a paradigm can even shape whenever you're doing the analysis and really deeply engaged with kind of in the weeds of doing the research, whether you decide to report a measure of reliability or whether you decide to engage in various methods to demonstrate trustworthiness. And so the key takeaway that I kind of want to emphasize from sharing all of this research is that understanding these paradigms, I think, is really necessary for reflecting on our own research and kind of seeing what paradigm our research aligns with and what perspectives we might be able to gain from other studies. And then also valuing and learning from the different kinds of research that might be different from the type of research that we're engaging in. And I think that understanding sort of the range of research and the underlying paradigms is really important for embracing sort of more comprehensive approaches for reaching shared goals to improve education broadly. So I want to end by kind of going back to those two questions I posed earlier about what it means to be engaging in research that sort of navigates between paradigms and whether my research aligns with my values. So in my thinking about this, I've relied a lot on this article in the Handbook of Research on Science Education, published in 2014 with the chapter by Tregest and colleagues, and sort of where I've come to be understanding kind of where I stand in terms of these different paradigms in my own research is really valuing the mixed methods approach that I've taken to my research. And I want to sort of end on this quote by Professor Jennifer Green that is quoted in the Trigust article, where mixed methods actively invites us to participate in dialogue about multiple ways of seeing and hearing, multiple ways of making sense of the social world, and multiple standpoints on what is important and to be valued and cherished. So I think this kind of active does a good job of summing up where I kind of have come in terms of my growth as a researcher and kind of understanding the paradigms that I've at points unknowingly engaged in. So with that, I would like to sort of end by re-acknowledging all of the different people who have supported me and helped me with the projects that I've shared today. All of these people have been wonderful mentors in my growth as a researcher. And I think with that, I can take any questions.
Excellent. Applause there. Thank you so much, Field, for sharing. We've got some really great engagement in the chat, so we'll just dive into the questions. Katie is asking, have you looked at how students use that automated feedback and whether it is effective in helping them understand what was not correct in their original draft?
Yeah, so that's a great question. So essentially developed the feedback tool in my final year as a PhD student. So all I had time really to do was to do some pilot interviews with students using the tool. So we haven't had the opportunity, or I haven't had the opportunity to actually see how effective it would be in students reflecting on their writing. But yeah, I really want to do that.
Very cool. We also have Sarah asking, this is super interesting work. Thank you for sharing. I'm wondering if and how do you imagine that the automated feedback could be used in combination with peer feedback?
Yeah, thanks for that question. So peer review is a key part of the writing to learn process. And some of my other research as a grad student also involved looking at peer review and really focusing on the value that peer review brings to these writing to learn assignments. So kind of engaging with this idea of automated feedback, I was a little concerned about the prospect of students kind of ignoring peer review because they have this automated tool now. So from the small pilot study that we did, just in doing interviews with students about how they might use the tool, we actually had a surprising result kind of across the students that we interviewed, where they mentioned how they would use both peer review and the automated feedback, and that they would kind of talk about how they would prioritize responding to the peer review comments first in their writing, and then kind of use the automated tool as like a double check to make sure there's nothing else that they need to cover. So I thought it was interesting that at least from that sort of interview setting, really small pilot study, students seemed like they would be using the automated feedback to kind of supplement peer review rather than replace peer review.
Nice. We've got another question here related to machine learning. Jessica asks, I appreciate your reflection about how paradigms influence how we generate new knowledge, especially your reflection about critical theories. I appreciated that too. How do you think about the role of machine learning in education, particularly given the broader dialogue about how artificial intelligence and machine learning methods can reinforce bias?
Yes, yeah. Thank you, Jessica, for that question. I think that was one of my main concerns, like doing this sort of more machine learning approach and looking at it as I was kind of simultaneously reflecting on how this research could be potentially harmful to students. So I do think that the machine learning approach can be very valuable in terms of connecting to students and really solving some of like the key issues, like practical issues that we're seeing in these classrooms. So just the example with the project that I've done so far in this area, the idea of developing these formative feedback tools, where actually in those interviews I mentioned, some students mentioned how they thought the tool would be really helpful because they didn't have access to the other resources that are already in place to support their learning with these assignments, because they have a busy work schedule and can't attend like office hours, for example. So I do think machine learning can, in general, provide an approach towards like improving access in some ways, by providing another way that students can engage and receive feedback. And then in terms of your question about reinforcing bias, I think that's where it's very important to be reflecting on these paradigms as we're doing this research. Because I think it's easy to kind of get excited, like I can develop these tools to automate the analysis that took me 2 years to do, and then we can use that to directly give students feedback. So it's really easy to get excited, and I think it's valuable to be reflecting on these questions of how like machine learning can reinforce bias. So I know there's a lot of work out there looking at this, and it is something that I personally want to like keep to investigate with my own sort of exploration of using machine learning in this classroom setting. So I think it's really necessary to be aware of the fact that you can kind of automate inequality in a sense by using the machine learning methods. And so if you're not reflecting on the fact that that is a possibility, I think that's where it can be a challenge.
Nice. And shifting gears a little bit, thinking about inter-rater reliability, Jackie is asking, during your reliability literature review, did you find any patterns in how people were engaging in inter-rater reliability discussions? For example, how they were discussing disagreement and coming to negotiated agreement, revising their code book, etc.
Yeah, thanks for that question, Jackie. So what I can remember from looking at those studies is that often, in my opinion, people would provide a measure and kind of move on. That seemed to be the most common way that people would report reliability if they were using those agreement measures. And it was kind of similar, I would say, in terms of the negotiated agreement, where they would say, we coded and agreed, like 2 of us coded together and agreed on how we were analyzing the data. I would say the researchers that were sort of leaning more on the naturalistic approach and discussing trustworthiness were a bit more detailed in terms of discussing disagreements, but in my opinion, it was often vague. So I think I've seen more recent articles in the last couple of years where there have been longer kind of discussions of exactly what those disagreements looked like and how they changed their coding scheme. And I think I've often seen those usually like in supplemental information. So I will say since then, I think I've seen a more recent trend towards being a little bit more transparent in terms of those discussions.
Nice. More questions about inter-rater reliability. Alina asked, how do you grapple with the quality criterion of reliability being inconsistent with qualitative paradigms, as you highlighted? Methodologically, where do you land on when and how to employ reliability as a criterion?
Yeah, thanks, Alina, for that question. So yeah, that was a big question that I was having. I was like, do I even need these reliability measures? Like, it doesn't totally align with like the qualitative tradition in general. And so kind of where I've come to land on when and how to use reliability measures is instead of thinking broadly of all research that looks at like interviews or writing or coding scheme, any research that I think would traditionally fall under that qualitative realm, I kind of think about if it's more focused on kind of analyzing maybe like how students are developing their reasoning or engaging in a learning environment, and maybe studies that are like using interviews and really trying to deeply understand how students are constructing knowledge, versus kind of the research with the writing analysis that I presented, where I kind of view it now more as content analysis. I'm looking at the writing to see what is present, and then using theories to guide like why it's valuable to look at what's present in students' writing. So kind of, I think where I land is that if it's more on the side of content analysis, I think it makes sense to employ the reliability measures as a quality criteria. But if it's more on the side of like how people are kind of constructing knowledge or engaging in sense making, or about how people are experiencing things, a lot of that is shaped by how the interviewer might interact with the participant. And I think it's a lot more valuable in that situation to focus more on the more naturalistic approach.
I like that. Kind of a broad question to maybe end us out here. For someone this is from Brian. For someone entering the DBER field, what advice might you give about how to go about gaining expertise and confidence in research methodology?
I don't know. I feel like that's a hard question. I guess what I kind of tell like the students I mentor, for example, is that they're the only ones who kind of know what they're doing with their project in detail. So as they're kind of going through their project, I think I've seen students kind of feeling that they don't really know what they're doing, but I tell them like they know what they're doing more than I know what they're doing oftentimes. So I think that doesn't quite get at your question, but I think yeah, gaining confidence with research methodology, just reading the literature and kind of seeing what people are doing, and then sort of in the situation like where I was looking at reliability, I was seeing these measures and I was kind of interested in how and why people were using these. So it really did involve like doing a whole literature review to kind of focus on that one tiny, often usually like less than a paragraph of all these articles. But I think just sort of gaining that exposure and kind of questioning what I'm seeing in the articles I'm reading has been helpful for that.
Very nice. In the interest of time, we're going to have to end. You can always send Field an email if you have any questions. Right now, there is a break, and then we're going to start up again at 11. So thank you so much, everyone, for joining. Let's thank our speaker one last time.